Hi folks, 2014 short questions. So we'll kick off there. So with A1, we have the goals here and we have a P from where a ball has been kicked. So it says the line PS in plan shows the start of a flight path of the ball for the first penalty kick. The ball crosses the goal line, which is here, at a height that is halfway between the ground and the crossbar. Draw the projections of the full flight path. So the first thing we need to find out there, we don't know where or what angle it was kicked up at, okay? But we do know it crosses here, at this point here. So if we bisect that there, we can start at P, go through there, okay? And that's where it'll hit up there. Now, we can then drop down this guy, okay? And we can bring him across also. We'll need this later on, that height. Let's get our compass there. It's coming back down along this way. Coming over, and if we run on PS, that'll be the flight path there, okay? P, of course, will be up here. And if we bring up this guy now, that is find us the point up there. So this would be the flight path in elevation, plan in view. So that's part A. Similarly, the line PT, which makes an angle of 15 degrees with the ground, shows the flight path of the ball for the penalty kick. So it's kicked here, it's going to hit the back of the net there. Okay, so we'll just assume 15 degrees is fairly low, okay? So we'll assume it hits there. Now, if we were to get our protractor, and what I'm doing is I'm kind of knocking this out to the side, okay, at the moment, just to find the height. Now that's 15 degrees there. So I'm assuming it hits the back wall here, 15 degrees, very low. So coming up there, 90 degrees, that will be the height then off the ground, okay? So if I take that height with my compass, I'm going to transfer it up here. Okay. That is where the ball, if it was kicked, would have that height. Now the reason we couldn't mark 15 degrees off there is we wouldn't be looking in at a 90 degrees, that would be an apparent angle, okay? So the height was there, so it definitely would hit that lower back part, and we'll just bring across this and bring up this guy, and that's where T would hit the back of the net when he kicked it, and the one from S would have been over there. And that's A1 done there, folks. Okay, so 15 degrees, got my height, set it off up here, because of that wouldn't have been a true angle, as we said, because it was an apparent angle, and transfer the height up, and that'll get you the point where the ball hit the back of the net, the flight path. Moving on to A2 there, folks. Okay, so in A2 here, we have the drawing on the right shows incomplete projections of a similar hexagonal prism which has been cut by the oblique plane VTH. Complete the plan of the elevation of the cut prism. Okay, so we can see the projection lines. They looked along the true length, or the horizontal trace there. So your projection lines will always come up and down, parallel to each other. Okay, so that's the two top lines there and there, coming back down. I'll bring these guys down first of all. So these guys that have to run into here, that guy run into there, and then we join them down. Okay, across and down to there. Okay, so that would be the face, the cut face there. Now, we're going to have to finish the elevation, of course, as well there. So we'll do that. We'll just transfer them guys up. and these two are on the ground. So this guy runs in as far as here. This guy comes in as far as here first. Then he's going to go down to that guy there. This one is going to continue over. And he is going to go down to this guy here. So I just need to extend that light construction line across there. And this one on the ground here. Okay, so that would be my cut surface there. Now part B then, as I just finish out shading this, is asking us for the true shape of that. Now we can see an edge view of the oblique plane here because we're looking along a true length there. Okay, so what we can do is we can just rebat this down onto the ground. So get your compass. Now these guys will come out at a right angle or perpendicular to the horizontal trace. So it's just like there, somebody came in behind that oblique plane there and just pushed it down onto the ground now, and we'll be able to see the true, this shape there cut up. Okay, so if you want to label it, you call it 1, 2, 3, 4, 5, 6. I always find this helpful myself. 4 and 5 will be there, 3 and 6, and of course 2 and 1 will be down the bottom. Okay, so 1 and 2 are going to be in the same place anyways. Follow the lines now. There's 3 coming out, 4 up here, 4 is on the far, 4 is up there, 5 coming out is on the top, and then 6 here must be here. So you can redraw that, join them up then, and if you get, some people wouldn't need to do that labeling, but I always find it a good idea. That's your true shape there, folks. Okay, and so we'll drive on there for now, but just put a bit of colour on that. And that there is our true shape. Okay, here. Now we'll move on to A3 next. Okay, so sorry, I've jumped onto A4 there. A3. So this object here, this cooking dish, is based here, it's told us, on 2 semi-parabolas, okay? And we have to finish these out, and we'll do that first of all in part B, then it's to do with the plan view, the ellipse. So we can see there actually, they've told us in the question, they've started setting this up already. So we'll just copy them. So we set our compass this distance here. That distance there, and then I'm just going to step that off. Okay, and this distance here coming down here, of course it must be divided into equal amounts each side. Oops. And this guy will come up to here. Second point, third point, fourth point, and then we can finish in our freehand curve. And these guys, of course, we just mirror them over. last one. Then we'll be able, forgot one there now, sorry. Do our freehand curve in then. Now down here, we've been asked there to finish out this object here. Okay, so it says draw a tangent or the complete. Sorry, now we'll just go back to part A for a second. So P is the point in the semi-ellipse. Small portions of the two curves have already been drawn. Complete the elevation of the tangent. Show clearly how the exact length of the base is obtained. Okay. So part B then, draw a tangent here to the curve at point P. Okay. Now, if you want to draw a tangent onto an object there, okay, what we're going to do is, I'm just rereading this. I just want to make sure we didn't miss part. The ellipse is not finished out there, so I'd imagine we'd have to finish that as well. So I just want to reread that. Right, so it's just asking us. It's not telling us to finish out the semi-ellipse there. It's just actually saying just draw a tangent to the curve at point P. Well, I can definitely do that. So we have the major axis there to there, with the minor axis up here. So one thing you'll need now is the two focal points. Okay, so if I put my compass down here, I get half the major axis. Put it on top of the minor axis and swing. That'll get me focal point 1 and focal point 2. There and there. Now, if you want to put a tangent on then, I'm going to join both focal points to the point P. And what we've got to do is we've got to bisect this angle here. So I'll do that quickly there. By bisecting that angle, we will get the normal. And then the tangent will just be at a right angle to that then. Okay, so bisecting that, that'll get me the normal. And then over here, just put on at a right angle then, the tangent must go at a right angle to that. Okay, and that's your tangent there. And so we'll move on now to part A4. The reason I stalled a bit there is I would always imagine you'd want to be finishing out that, but it doesn't say it in the question. So that the tangent was all it said, so we've done that. We'll move on. Coming to the last one here now. This is partially set up, it's perspective. So the position of one of our vanishing points, VP2, is shown. Locate the other vanishing point. Well, how do we get a vanishing point? All the lines are running in two directions. You put it down, you go to the spectator, draw a line, and where it hit there, you come off at 90 degrees. And we'll do the same thing the other side then. So put down that, draw a light line over there. I might do this in orange. Okay, where it hits the picture plane, we're going to drop down there at 90 degrees. That gives VP1. Now all lines will run to VP1 or VP2. So this is the netting on the table there, okay? And so what we're going to do there now is we'll drive on with this guy here. So with the back of the table there, so connect it up there to VP1 lightly. Okay. Find out where the table ends, or any point you want. Draw to the spectator, or across the picture plane. Come down to 90 degrees. And that'll get me this point here. And from there, then I can just run that guy back to vanishing point 2. That'll be the heavy outline there. Okay, and we'll need these points as well then. So just eyeball it up there. You don't have time to be going sliding set squares. Get it as good as you can there. Then I need the middle here. I want this point. Give me the midpoint there. Then I can put in that line there. So that's the table itself finished out. Now the last thing they were saying there was to get the true height of the net. But if we did have the true height, one thing we might do sometimes we slide down a shoulder line. Okay, and we can measure up off that then. But the reverse is true as well. So if you bring down this guy, do this in red, bring down that guy to there. And if you bring down this guy as well, if you do a line coming up here off this now, vertical line, okay, that is the height there that they're looking for, the true height of the net. Okay, so that's that question finished. Hope you found that useful, folks. Keep tuned. I'm going to keep making all of these short questions, the surface geometry questions, which is C3, and the road questions as well every week. Okay, take care, folks.